Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we are going to talk about another type of plot that can be particularly useful in characterizing the nature of a dataset. The plot that we're going to be talking about is the quantile plot. The purpose of the quantile plot is to depict in sample form the cumulative distribution function, the CDF. Remember that? Remember that from statistics 256? Okay. So, now, a normal quantile plot, or normal QQplot, or just QQplot, is a plot of the empirical, meaning sample quantiles, against the corresponding quantile of the standard normal distribution. As we mentioned before, we often make the assumption that observations in a dataset are normally distributed. So QQplots will serve as another diagnostic plot to check this. Okay, let's begin. So I would like you to understand how these QQplots are constructed. Okay? So we're going to discuss an example with a small data set, and we're going to make our QQplot step by step. Okay? So as you can see here, the first column of that slide has 10 observations in it. Okay, the observations have been already arranged from smallest to largest. Okay. Now, what we said is that a quantile plot is basically an estimate of the CDF, the cumulative distribution function. So, for instance, if we wanted to estimate the probability that the random variable x that generated these 10 numbers is less than or equal to -1, a possible estimate would be, well, probability that x is less than or equal to -1, 1 in 10, 0.1. Probability that the random variable that generated these numbers is less than or equal to -0.1, 2 out of 10, 0.2, right? So that would be those would be possible estimates for the CDF evaluated at these points. But here, note, these are slightly modified, right? Instead of 1 in 10, you take 1 minus 1/2. It's going to be just 1/2 divided by 10, right? So instead of it's going to be just 0.5 divided by 10, 0.05. So instead of 0.1, you have 0.05. In this case, we said, well, it could be 2 out of 10, so it would be 0.2. But in this case, what we do is, well, this is the second observation, 2 minus 0.5, 1.5 divided by 10, 0.15 instead of 0.2, right? So by doing this version, we are contemplating the possibility that we could have, other observations to the left and other observations to the right, right? Because if we reached this point, at this point we would have 1, right? If we just did it like we were saying at first. With this modified version, again, we take into account the possibility of that you could be observing, there could be out there values that are bigger, and in this case, values that are smaller. Make sense? Okay. Now, if we made a graph of these guys, the ordered observations, against these, that would be again an estimate of the CDF for that variable. Let me show you. Let's launch R. Let's enter the observations. Let's call them observations. Let's use C function, so -1, -0.1, 0.16, 0.41, 0.62, 0.8, 1.26, 1.54, 1.71, and 2.3. Okay, let me check that we have 10 observations. We have 10. Okay. Now that's the first column, the observations. Now let me create the second column that we have here. Okay, so let me call those guys probs, as in probabilities. Okay, let me create them like this. Let me show you something. If we use the following command, sequence, and then the syntax is starting point, ending point, and the difference between them, right? So, and remember that J represents the order of the observation, right? So what I'm trying to create is that, right? That J. Okay, so that guy would be my J minus 0.5 would be the numerator of these probability levels, we call them. Okay, that would be the numerator, and then I would like to divide that by 10, which is in this case the sample size n, right? Okay, so I would have 0.05, 0.15, 0.25, and so on. Okay, so let me save that in an object called props, just props. Okay. Now, as I said, a quantile plot would be just a graph of the observations against these estimates of the cumulative of the CDF, right? Evaluated at those points. So observations, props, with PCH equals 19, I'm going to be creating a plot with solid circles, and I would like to see those guys blue. Okay. So it looks similar to those CDFs that you learned about in Statistics 256. Remember that CDFs have a few properties. They are non-decreasing as the random variable x goes to infinity. They go to 1. As the random variable x goes to negative infinity, they go to 0. Right? So yeah, it seems to be an approximation of a CDF, right? But this is just a quantile plot, okay, not a QQplot. Our QQplot is going to be a graphical representation of the first column against the third column. Okay, the connection between these two guys is going to be the column in the middle. Let me show you. For instance, we know that, for instance, for a normal, right, if we want to find the number that has 50% to the area underneath, the 50% probability to its left of a normal 0, 1, and note that with QNorm the default is a normal 0, 1 or a standard normal, right? So if we know that the quantile, right, the number such that the area to its left is 0.5, it's just going to be 0 because it's a normal 0, 1, right? So the area to the left of 0 is going to be 0.5. Normal distributions are symmetric. The mean is the center, so it makes sense that the area to the left of 0 is 0.5. Okay. Now, so going back to this, using that QNorm function, we can find the quantiles, meaning the numbers from a normal distribution, such that the area to their left are these numbers here in the second column. So let's find the first one. Okay, I claim that the quantile, the number from a standard normal that has an area of 0.05 to its left, is negative 1.645. So let's use again the QNorm function, but now with 0.05. Yeah, I just rounded these. Okay, we could do the same for the next one. Hey, tell me what's the number from a normal 0, 1 that has an area of 0.15 or 15% to its left. Make sense? Okay, so, but note that those guys are props, are these guys, right? 0.05, 0.15, and so on. So I want to find them all. So let me find them all just like this. If I apply the function QNorm to props, since QNorm again is going to find quantiles for a standard normal by default, that's going to do the trick, right? So I get the entire third column. Okay, let me save that in an object that I'm going to call norm quantiles, as in normal quantiles. Okay, so finally what we're going to be doing is plotting those normal quantiles, the theoretical ones, against these guys. Okay, so quantiles from a normal against these guys, the sample quantiles. Okay, let me do that. Okay, that's the simple version of a QQplot done step by step by us. Okay, let me make it look slightly nicer. Let me, for instance, add a label for the horizontal. Let me call it theoretical and then this one for the vertical one, sample, and main title. What I want is, this is ours because we made it step by step. Let me use blue for the color and PCH so we have solid circles. Okay, So we have hours, that's the main title, that's a sample, those are the theoretical ones, right? And again, we did this step by step, and basically what we did, let's review what we have done up to this point. We had a sample, we ordered that sample from smallest to largest, we came up with an estimate of the CDF from that sample, and then we computed quantiles for a standard normal that corresponded to these probabilities, right? And finally what we did is we graphed these, the theoretical quantiles. We use these for the horizontal axis against these, the sample quantiles, for the y-axis, for the vertical axis. Okay? Let me show you how to do this using R. Okay? So using R, we use the function QQnorm. Okay? So it's a normal quantile to quantile plot. Okay, and all you have to do is, hey, give me your sample, your observations. How about, let me make it red. I want solid circles. See? Exactly the same as ours. If you want to see them side by side, we could do this. Par mf row. So what I'm doing here is I am basically asking R to prepare kind of a matrix of plots. It's going to have one row and two columns. Then I'm going to plot hours first, and then I'm going to plot the one we get from R. Okay, so as you can see, they are identical. Okay, makes sense? So that's using base R. Okay, as I mentioned before, a very popular library, a very popular R package to create graphs is QQplot 2. So let me show you how you can create a QQplot using QQplot 2. Okay? So first, again, remember, if you're going to be using that R package, you need to load it first. Okay, so first you have to install that package, and once you have done that, you don't have to do that again. You don't have to install that package every time, right? But every time that you're going to use it, you must load it with that command, library, and then the name of your package. In this case, QQplot 2 is the one we want. So we already have our observations, right? Those are the ones we want. But now we have to do something, an intermediate step. It turns out that QQplot likes dealing with data frames. So we're going to turn our vector of observations into a data frame. And then I'm going to call that guy just df. Okay, so as usual, QQplot, then first data, right? The data that we want to use is df, that data frame we just created. The mapping, that is going to be telling QQplot which variables we are referring to. It turns out that for this particular kind of graph, the instead of using x and y, the argument that we need is sample. Our sample is in ops. Okay, and you know that by doing this, just this, you prepare your canvas. So nothing. Yeah, it's just the canvas. It's just setting it up for us. Now, to actually graph that QQplot, you need geom QQ, open and close brackets, and there you are. Okay, QQplot using ggplot. Okay, so another way of doing this, just let me show you something. Once you become comfortable with ggplot, you will start making a few changes like this one. Okay, slightly different version. Another way of doing this is first with ggplot, you just let ggplot know the data set that you're interested in, and then you let ggplot know the variable that you want to use for the QQplot here inside the geom_QQ function. That should work as well. Let's see if I'm right. Yeah. So anyway, but the basic syntax is this, right? You want your data, then your mapping, and then the kind of graph that you want. And again, see that we have the same structure as before. ggplot to prepare our canvas, plus meaning you add a layer to that canvas, and in this case the next layer is a QQplot. If you want it, for instance, a histogram, you know that it's going to be really similar, right? Instead of geom_QQ, it's going to be geom_histogram. Make sense? Okay. So, finally, just for fun, and because I want to give you a preview of what we're going to be doing in the near future, we said that this is going to be a graphical way of assessing normality. Okay? So, let me create a vector that contains numbers that come from a normal distribution and see what a QQplot looks like. Okay, so let me call it sample1, and I'm going to be using R norm to generate random numbers coming from a normal, right? And let me generate 200 of them. Okay, and say that they have a mean of 5 and a standard deviation of 2. So we know that if we're going to be using, for instance, base R, the command that you need to use is just QQnorm and the name of your object. Okay, so let me use that one. QQnorm of our sample, it's called sample1, and let's do this one green. Make sense? Okay, and you could add a line, QQ line, for sample 1. Note how close these guys, the green dots, are to that line, to forming that perfect straight line. So when you have numbers that come from a normal, these guys will be close to forming a perfect straight line, right? If they are, and well, we know that you know, due to just random variation, not all of them are going to be exactly there, right? So even when they exactly come from a normal, right, they are not exactly there, right? But they are very close to forming a perfect straight line. Now, on the other hand, let me create a sample, but now coming from an exponential distribution, right? And the rate is, you know, the mean is by default 1. So I'm going to be using that. So let me generate 200 pseudo random numbers, because they are not, okay, anyway, random numbers coming from a normal, from an exponential, right? That's going to be my second sample. And now I'm going to be making a QQplot for that second sample. Let's make those guys, I don't know, purple. See? And when you add that line, the theoretical one, so these guys, the purple dots, are very far from that line. They are very far from forming a straight line. So in that case, that normality assumption is questionable. It is not very reasonable. Okay? Okay. So, let's summarize what we have done today in this video. Okay? So in this video, what we talked about was QQplots, or normal quantile to quantile plots. Okay? And we are going to be using these to assess normality in a graphical way. Okay? And basically what we said is that the let me show you the other one, the one for the first sample. The closer those points are to forming a perfect straight line, well, if that's the case, the assumption of normality is reasonable, right? But if our QQplot, it's very far, the points that form our QQplot are very far from forming a perfect straight line, then the assumption of normality is not that reasonable. It might be in question. Okay? It's questionable. Okay, so that's it for now. Thank you so much for watching. Please take care and keep working hard. See you next time. Bye.